Good morning, everyone. My name is Abigail Skena, and today I will be presenting my Keystone project on how I assessed predation pressure in a tribal fishery, guided by optimal foraging theory. This was a project kind of guided by conservation biology and behavioral ecology, so it was a really cool intersection, and I'm excited to share it with you guys. Before I get into all of that, I do want to take a moment to acknowledge my amazing team that helped me with this. Dr. Maria Abate is the lead biologist for the Wampanoag tribe of Gayhead Equina, which is located here in Massachusetts on Martha's Vineyard. And she's really helped me every step of the way and has taken me on. So I super appreciate that. I'd also like to thank everyone else at the Wampanoag Tribe's Environmental Lab. They've really helped me out. Everyone in the Natural Resource Department has done such a good job mentoring me, and also to my Kilachand advisor, Dr. Peter Buston. All right, so I want to introduce the study taxa of concern. First, we have the river herring. The river herring is a culturally significant fish to the Wampanoag tribe, but it also has a lot of uses for sustenance, including both food and fertilizer. And this species, which was once in the millions, has now declined to only 12,000 on Martha's Vineyard. So quite literally from millions and millions running in every year to essentially one net full of fish. This is very concerning to see a decline of such orders of magnitude. And the issue here that we're primarily seeing is an issue of human behavior. So this is an anadromous fish, meaning like salmon. This fish runs into freshwater systems every year, but it spends about 9 months of the year in the ocean. So while this river herring is in the ocean, it's a victim to commercial fishing bycatch, and then it's unable to reach the freshwater points to spawn each year. So that's why we've seen such a drastic decline, is primarily due to commercial fishing. Then we have the striped bass, which is also an anadromous fish, and it's the key predator in the study system that preys on those river herring. The striped bass is increasing due to climate change. Warmer waters means that the striped bass can stay within the study system for much longer. In fact, we're thinking that they're staying the full year rather than migrating down south in the winters. So we really wanted to take a moment to assess kind of the local predator-prey relationship between these two and see if the increase of the striped bass in the system is exacerbating the decline of the river herring in the system. So this is the study site that I worked at. This is the Wampanoag Tribe of Gayhead's Environmental Laboratory, and they've essentially placed a fish weir with an underwater camera within that system around point C on that diagram. And what this is it's a point where the ocean kind of blends into brackish creeks. We call them ponds, although they are still brackish. And this is really important for the river herring because this is how the river herring make their entrance each year to get to that spawning point in D. They have to enter through point A and make it through all of that area, which can be kind of a death trap when there's a lot of striped bass waiting for them. So what I actually did to assess whether or not this is becoming a problem, I'll get into in just a second, but I want to take a moment to kind of address the theory behind this project. So this is called optimal foraging theory, and essentially it's a game theory-based approach in behavioral biology that explains why an animal chooses to stay and continue foraging, hunting for fish essentially, or whether it will leave and move out of the system. And essentially, it predicts that an animal will maximize its nutritional benefits while minimizing its overall energetic cost by getting the timing right on when to leave a depleted forage patch, hopefully find a more nutritional source, versus staying and kind of depleting that foraging patch itself before moving on to the next one. So it's really a game in timing, and we can kind of observe this happening based on the bidirectional movement of fish within the system. So that's where the research question comes in, which is essentially asking, when river herring decline, do movements of their predator increase as optimal foraging theory would suggest? Essentially, are the striped bass becoming better predators as the river herring continue to decline? So the hypothesis states that when herring run activity is low, so for example, in the study year of 2024, our most recent year of data collection, we saw only 12,000 herring, which is a pretty relatively low year. So in that case, we would expect to see a lot of foraging behavior, a lot of that back and forth bidirectional movement from the bass. Versus a more high run activity, which is more energy rich, like the other study year I looked into, 2022, when we had about 3 times as many herring in the run that year. we would expect to see less foraging behavior, less back and forth within that system because both of the foraging patches are so energetically rich. There's not as much incentive to move back and forth. So, guided by these questions, what we actually did was we analyzed herring cam video from 2022 and 2024 on a daily scale. So that underwater camera I mentioned earlier, it exports files that we can go through and mark all of the behaviors that we witness. Historically, fish tick videos and herring cam videos have only been used to get population counts, so we know how many fish are there. But this study is kind of novel in that we went back and used that data in a new way and tried to assess the actual behavior of what was going on in the system. So that's what we did. We scored the fish tick software for basically every time that both taxa passed by the camera, and then also mentioned the direction and the timing of those pass-bys. And then we conducted statistical analysis in which we basically compared the bass foraging behavior, the back and forth movement and timing of it between days of the lowest 25% of herring presence and the highest 25% of herring presence within the full run. So what did I find? I did have statistically significant results, which is always fun. So basically we found that in 2022 specifically, which was that year of relatively higher herring presence, we did see a significant difference between the lowest 25% of herring presence days and the highest 25%. And it did support hypothesis one, that as we see essentially days of lower herring presence, we would expect to see a more optimal predator moving back and forth within the system, which represents a heightened threat of predation on this declining species. This trend did hold in 2024 as well, although not quite as strongly. But for a variety of environmental factors that differed between the 2 years, we couldn't necessarily make direct comparisons between 2022 and 2024. So to conclude, from the study we learned a lot. We learned that herring cam data can be useful to explore species interactions, not just general population counts. We can extract more information than we thought from this data that's already being collected anyways. And as the tribe learns more about the changing Herring Creek, this study has provided insights into how the striped bass are responding, as we expect to see the herring numbers continue to decrease as size limits have not been set on the commercial fishery recently. We found that integrating classical foraging theory and non-invasive tribal resource monitoring, such as the cameras rather than tagging systems, can be a powerful tool for natural resource management. And finally, just taking it back to the core of this project, it's a story of how human behavior has altered natural systems. So it's important that we learn, kind of gain understanding of how we're altering these natural ecosystems and kind of the trophic cascades that are happening as a result. And we just wanted to look into that, and we found some pretty cool insights. So thank you. Does anyone have questions?
When did they start to see this drop off in the population? Was it pretty gradual, or was it a sudden drop?
Yeah, so this decline in river herring has been happening. Obviously, I emphasized what's been happening in this study system, but it's been happening all along kind of the North American seaboard, specifically New England. Maine, interestingly, is the only state that hasn't had severe river herring loss because they have such strict commercial fishery policies in place. And that's not something that Massachusetts has. It's also something that was recently voted on and was voted to push that decision back to 2027 again. So decisions like that are clearly impacting these study systems. It's happening all over New England, but it's been happening for the past few decades. So 12,000 is a severe decline, of orders of magnitude we haven't seen in a very long time. But the study system used to literally be described as you could walk on the water. That was how many fish were there. So definitely concerning. Yeah. Mm-hmm.
What drove you to do this study, I guess? Or what was the influence for you?
Yeah, I would say, honestly, my advisor was a big influence. So this is kind of my study niche. This is what I want to go into, is kind of the intersections between environmental science and marine science. And so I started kind of looking for a research project with that, and I met with Dr. Abate, who is the lead biologist at the Wampanoag Environmental Laboratory. From there, I got to go out to the study site on Martha's Vineyard a few times, meet everyone in the lab, help them with other ecological monitoring projects. And it just really grew. It originally was not supposed to be my honors thesis. It was supposed to just be one semester of Europe, but it really grew into like a project that I care a lot about, and a project that I'm really glad I got to help them out with, because there are some management implications for what we found.
What are those management implications?
Yeah, so currently, there's two issues at play. Essentially, the biggest issue at play is that the tribe can't do anything about the commercial fishery. That's not on their lands. It's not something they have jurisdiction over. So any bycatch that happens, any threat to their natural resource of the river herring that happens that's away from their land, they can't do anything about. However, we can do things that are within their own land and within their own study system. So that's why we were looking into the specific local predator to see if we could adjust essentially how we treat the striped bass in the system. So for example, right now, the striped bass fishery has been closed to, they do like an annual derby that you're not allowed to catch striped bass. Within Aquinnah specifically, Massachusetts, only tribal members are allowed to fish striped bass and only in certain locations. And so that's something that the tribal council can decide that they would want to open that fishery to non-tribal members, or open it up, expand kind of the places that they're allowed to fish. And that's also something that the New England Fisheries Council as a whole could reduce the restrictions on those striped bass fishing. Oh, yeah.
Time for one more.
Sure. Anything that you would have done differently now that you finished the project?
Ooh. I mean, ideally, we would have gotten more study years, because as I said, 2022 versus 2024 was a pretty rough comparison. We chose those years because it was there's such contrast in the herring run, so we wanted to see if the trend held between a super high year and a super low year. But in hindsight, there were a lot of environmental factors, like it was a much colder winter. The camera position itself changed between those years. They moved it closer to the lab. So ideally, I would rather have kind of more study years to add and kind of discriminate between just like one-off trends and larger trends. And that's something that I hope to train an undergrad to continue doing once I graduate.